we're going to talk about continue from the left and continue from the right. Okay. Function f is continue from the right at a if the right-hand limit equal to f of a, which means you can do a direct substitution, substitute this a into this x to get the limit. Similarly, continue from the left if the left-hand limit equal to f of a. Now here is one example. You see this graph right here. When x approaching a from the left side, f of a here, because this is a solid dot, f of a is equal to the left-hand limit of the function. So this function is continue from the left. This one over here, if you go approaching a from the right, you see this is a solid dot over here. The right-hand limit of the function is equal to f of a. So this function is continue from the right. Now, if you're looking at the graph, if you see it's a solid dot like this, then we can tell this is continue from the right, and this one here is continue from the left, the solid dot over here. Okay. So here's one more example. This function over here, if you go from the here 0, if you're approaching 0 from the left, you see the solid dot over here. The left-hand limit is equal to f of 0. So this function is continuous from the left at 0. What about on the right? Well, when you take the limit of the function as x approaching 0 from the right side, the limit over here is going to go to this value. However, it's different than f of 0. You see, this is an open circle here. So that's not equal to f of 0 here. So this function here is not continuous from the right at 0. In other words, it's discontinuous from the right at 0. And you can see this is open gap right here. Okay. So solid dot here, continue from the left. Open gap here, discontinue from the right. Okay. Another definition, the function is continuous on an interval if it is continuous at every number in the interval. So if f is defined only on one side of an endpoint of the interval, we understand continue at the endpoint means continue from the right or continue from the left. Okay. Say over here, the function is continue on this closed interval a to b. If f is continue on every number in this closed interval a to b, at this endpoint, the function is continue from the right at this a and continue from the left at this b. Okay. Next example, we're trying to prove that this function is continue on this closed interval from -1 to 1. So first of all, this is a closed interval. Let's consider the open interval from -1 to 1 first, and then later on consider the two endpoints in the second case. Okay. Now, on this open interval from -1 to 1, limit of f of x is equal to the limit of this function. Okay. Now, by the difference law and the constant law, we can rewrite it into 1 minus the limit of the square root of 1 minus x squared. And now by the root law, we can take this root and bring the limit inside this root. So this will become, because square root is a continuous function, so you can bring this limit inside this square root. So this is the square root of the limit of 1 minus x squared by the root law. Now, when you take the limit of this by the difference law, constant law, and also the power law, then we can just go ahead and get 1 minus a squared for this limit. Okay, because this one here is a polynomial, so you can just go ahead and do a direct substitution over here to get this limit right here. Okay, so this result over here is the same as you just direct substitute a into this x over here, which is the same as f of a. So the limit of the function as x approaching a is equal to f of a, by definition, the function f is continuous at a. So the function is continuous on -1 to 1. Now let's consider the 2m point. So let's think about at -1. So we're going to take the right-hand limit over here because this is the left-hand point. Take the right-hand limit over here. Then we're going to use similar calculation above as in case 1. We're going to get this is equal to 1 because we're going to get 1 over here. Okay, so if you substitute -1 over here, you also get 1. Okay, so the limit as x approaching -1 from the right side is equal to f of -1. Then the function is continue from the right at -1. Similarly, at this m.1 over here, we take the left-hand limit. So take the left-hand limit of the function, and by similar calculation above as in case 1, that is equal to 1, which is the same as you substitute 1 into the x into the function. So the left-hand limit equal to the function value. So the function is continuous from the left at 1. So by definition 3, function is continuous on this closed interval from -1 to 1 because it continues on every number on this open interval -1 to 1 and continue from the right at this left endpoint, continue from the left on this right endpoint. So the function is continue on this closed interval from -1 to 1. So this is the end of the proof. Notice that what's the graph of this function, f of x? Well, let's think about this. F of x over here, you can just replace that by y. So y is equal to this. Now, if I subtract 1 on both sides, so y minus 1 is equal to negative square root of 1 minus x squared. Now, when you square both sides, then the square root here is going to cancel with the square. So that is going to give you 1 minus x squared over here on this side, y minus 1 parentheses squared on this side. If you move this negative x squared to the other side, become positive x squared. So x squared plus y minus 1 squared is equal 1, which is a circle. Remember, standard equation of a circle that we just reviewed is this one. And the center for this circle over here, it's 1, with the radius over here being 1. Now, the graph of this is not the whole circle though. It is only the lower half of the circle because this minus sign over here. Okay, you can see because this minus over here. So it is only the lower half of the circle. If this is a plus over here, then this will be the upper half. But it's a minus here, that's the lower half of the circle. Okay, all right, because you see the y value here is always less than this 1. So it's going to be below 1. So the y coordinate is going to be below 1. So it's the lower half of this circle.